All right, here is 8.3.2 for 7th grade. What kind of angle is it? And I'm starting us here, and we're probably going to stay at the computer the whole time because we have angles we need to look at. So it says, if you look around you, you'll see angles everywhere. Angles are important in construction, sports, and art. In the previous lesson, you learned how to measure angles using a protractor. Today you will classify angles, and that means categorize them, and use your protractor to identify special angles. All right, so 866. In geometry, an angle is formed by two rays with a common endpoint. A ray is a line that has an endpoint and extends indefinitely in a particular direction. So that means kind of like forever. The point where the two rays intersect is called the vertex. So there should be some review. Here's a ray, and they meet at the vertex. One of the most common angles is a right angle that measures 90 degrees. If an angle measures less than 90, it is called an acute angle. If an angle measures more than 90 but less than 180, it's called obtuse. Okay, so we reviewed that today during our Google meeting. So now here's how you would use a protractor. So you'd set up the little dot, the ray, or the vertex, sorry, wherever the 0 degree mark on your protractor is, and it'll show you on the protractor. It kind of depends on what protractor you're using. And then you line it up so that this horizontal line is on the bottom. And then you look up here, and this would make sense that that's 50 degree angle because it's less than 90. It's not 130, obviously. 130 would be over here, and it would be like a big obtuse angle. Okay, so that's going over some review. Let's use my protractor now to find the measure of each angle, and we're gonna classify it according to its measure. I'm gonna do my best to do this one-handed, and it's gonna be quite interesting. So let's see what happens. All right, so here's my 0 degrees is actually right here, or my 180 degrees is right here. So it's actually in the middle of this little ruler where that tiny dot is. That's where I'm gonna line each vertex up. Okay, so there's my lining it up and the vertex. And if I kept extending that line, it looks like it would be, what, about 35 degrees? Yeah, it looks like it would be in between, where's my thumb, 30 and 40. Okay, so that's, I would say 35 degrees for part A. Let's look at part B. Ooh, blue paper, jeez. All right, one-handed, here we go. Lining it up so that one line is, come on. There we go, lined up. So now I'm looking, now we're at the 0 degrees, so it's gonna be an angle that's bigger than 90 because it's obtuse, and it looks like it would be about 115 or 110. I think, I put 120. All right, I'd put 120 degrees for that one. Last one, part C. Let me do it with my right hand this time. So if I lined it up here, there we go, it's all lined up. Oh, 90 degrees. It's pointing right at 90, so that would be a 90 degree angle. All right, so that's part D. A straight line is also called a straight angle. Draw a straight angle on your paper. What is the measure of a straight angle? I believe we went over that this morning on the Google Meet, but I'll show you my drawing. I drew a straight line, and then I drew that little half circle to show that's the angle, and it's a 180 degree angle. Okay, it's also called a straight angle. Okay, 867. 867 wants us to look at how these students use protractors and explain what each student needs to do to find the correct angle measure. So they did something incorrect with their protractor. So let's look. For part A, it looks like to me they've got the horizontal line going on down here, which is good. It's lined up, but their 0 degree mark is, oh no, they're good. They need to be in the middle. Okay, so they're not in the middle. So I said to put the vertex at the vertex of the protractor, which would be right here. So they need to move that baby over. All right, let's look at part B. To find the angle that they use. So this is actually, they did it one way that you could do it, so it's not incorrect, but you would you'll notice that we've got this one pointing at 30, 150 and this one pointing at 80, 100. So we're going to have to take, let's subtract 150 and we're going to subtract 80 to get the measure of our angle. So that would actually be a 70-degree angle if we did 150 minus 80. All right, let's look at C. So it looks like C, they did not line up their vertex on the 0 degree, because here's where 0 degrees would be, right here. They lined it up at like, what, 165? So that's incorrect. They need their vertex at 0 degrees. Last one. So they put the measure of angle, the angle is 60 degrees. That is incorrect because 60 degrees would be less than 90. It would be right here. So that's where the 60 degrees would be. So you have to read the bigger number for this measure. So it shows 60, but it's obviously not 60. It has to be 120 since it's obtuse and it's bigger than 90 but less than 180. All right, so there we are for 867, learning about protractors. Okay, some vocab coming at you. You'll notice with geometry, there's always like a lot of vocabulary going on. So here we go. We've got complementary angles. Those are two angles with a sum of 90 degrees. Supplementary angles are two angles with a sum of 180 degrees. So we're going to use our protractor to measure each of our angles and determine which are complementary and which are supplementary. Where is my protractor? There it is. All right, so let's do angle A. Let's measure it. Sorry if I'm making you dizzy here with my camera work. All right, where am I? There we go. So I know my protractor is quite big and it's hard to see where the line's gonna go, but it looks like the line, I think I put on my paper, it's at 120 degrees because it's an obtuse angle and it looks like it's pointing to 120. And I'll tell you the actual answers after this because it's kind of funny what CPM's answers are. All right, for this angle B, it looks like it's pointing towards, I put 60 degrees, but it looks like it's in between 50 and 60. But I'll tell you that, oh, I'm gonna keep going. This one, what am I doing? There we go. It looks like it's pointing and it's an acute one, so it's probably about 40. But then I looked on the CPM answers and I'll show you, they were very exact. So they had a nice protractor to work with. So I'll show you, whoa, where's mine? Okay, so for angle A, I put 120, but CPM actually got 127. Angle B, I got 60, but theirs was 53. And angle C, I put 40, but it was actually 37. So they were way more precise. And I would probably write theirs down because the next part that I'm gonna do is we need those exact measurements. So which ones are complementary and which ones are supplementary? So complementary are two of them that will add up to 90. So which one, 127, 53, and 37, which two will add up to 90? Kind of obvious. Looks like 53 and 37 are going to be our complementary angles. And then our supplementary angles that add up to 180 are going to be the 127 and the 53. I think I wrote that. Yep. So angle B and angle C, complementary. Angle A, angle B, supplementary. All right. Oh, and then for B, it wanted us to come up with a way for remembering that those two definitions, like a little like shortcut or like little hint or something. You can come up with your own, but CPM came up with, well, C comes before S, so complementary angles have a smaller measure. So if you just remember, complementary starts with C, comes first in the alphabet before S, so that means complementary angles have a total that's less than supplementary. I don't know. You guys can probably come up with a better one. Okay, let's look at adjacent angles. So angles that share the same vertex and one side are referred to as adjacent angles. Adjacent in English means next to. For two angles to be adjacent, they must satisfy the following three conditions. Number one, The two angles must have a common or a shared side. They must have a common vertex, so a common starting point for all sides, and they can have no interior points in common, so no overlap. The common side must be between the two angles. So I want you to copy each of the figures below on your paper, determine which pairs of angles are adjacent and which are not by checking to see if each angle pair satisfies these three conditions. Write yes or no to each figure. If you write no, give a short explanation. Let's look at A. So adjacent would be angles that are right next to each other. So let's see, are these adjacent? They have a common vertex, yep. They share the same side, yep. And they can have no interior points in common. There's no overlap, and it doesn't look like it. So those angles for part A, 1 and 2, yes, those are adjacent angles. They're right next to each other, and they satisfy all those criteria. Part B, this looks a little wonky. It says, do they share a common vertex? Well, angle 1 is vertex is right here, and angle 2 is vertex is right here. So no, they don't share a vertex. So automatically, no, those are not adjacent angles for part B. Let's look at part C. Looks like angle 2 and angle 1. So here they look like they share a vertex to me, but it looks like there's some overlap going on. So 2 is overlapping 1, which can't happen with adjacent angles. So that means that angle 2 and angle 1 are not adjacent angles because there's overlap. All right. So we're only going to do, oh wait, I did D2. Let's look. Do we think angles 1 and 2 are adjacent? Well, they are next to each other, but they're not coming together to form the same vertex. Okay, so those would not be adjacent. So the only one that was A. If you want to do the rest, you can, but they're not required. All right, 8-70, almost done. Okay, now a new type of angle is a vertical angle. Angles formed by two intersecting lines that are not adjacent are called vertical angles. In the diagram at the right, angles 1 and 2 are vertical. So here's angle 1, here's angle 2, and those are called vertical angles. Okay, so they're like opposite. What can you say about angles 3 and 4? Well, let's look at 3 and 4. There's 3 and there's 4. Those are also vertical angles. Part B, use your protractor to measure each of the 4 angles. And what do you notice? So I'm just going to skip through this part. So I already measured them with my protractor, and I got angle 2 is 30, angle 1 is 30, angle 3 is 150, and angle 4 is 150. So 1 and 2 are both 30, and angle 3 and 4 are 150. So we notice they're 3 and 4 are equal, and 1 and 2 are equal. Let's look at part C. Draw a pair of vertical angles on your paper. So you probably don't need to do this part, but you'll watch mine. Measure your vertical angles. What do you think is true about the measures of vertical angles? So here's mine that I just drew. So I saw that angle 1 was approximately 120 degrees, and angle 3 was approximately 60 degrees. So it means vertical angles are always equal to each other. So angle 1 and angle 2 would be equal because they're vertical, and 3 and 4 would be equal because they're vertical angles. Whew! Almost there. Last one. And we're just doing A. 871A. Find the measure of the missing angles. So angle 1, we have 75 degrees. Angle 2, we're trying to figure out. So I'm wondering how we could figure this out. Well, it looks like they have a straight line going on, and it looks like there's my pencil. If I were to draw like a half circle, we would get 180 degrees. Whew, been talking a lot today. 180 degrees. So if we know angle 1 is 75 and the whole thing is 180, how can we find angle 2? Well, you might already know. I subtracted 180 minus 75, and I got 105 degrees for angle 2. So angle 2 is 105 degrees. Those are supplementary angles. They add up to 180. You can do some more practice if you want on those ones. They are not required. But that's going to conclude. Wow, I got through that one faster than I thought I would. So that is the last lesson for this week, and let me know if you have any questions. See you later.